Hello, Integrated Math 1. Welcome to lesson 2.4.1a. We're going to start talking about shapes in the coordinate plane, but before we do, we have some important things that we need to make sure we got solid under our belt before we get too far along. So I do have a short warm-up here for you today. It is on page M2-247 in your workbook. Actually, there's several of them in your workbook. I'm only asking you to do the first one, but there are others. I just want you to determine the length of the hypotenuse, and if necessary, round your answer to the nearest tenth. So you are going to want a calculator handy. And if you forgot, remember with right triangles, remember we have Pythagorean Theorem. Is this ringing a bell? Right? Do you remember this? A squared plus B squared equals C squared, where if you have a right triangle, there's my right angle, that sides A and B made the right angle, and then C is your hypotenuse. C is the side across from the angle, opposite the angle, right angle. It's also always your longest side, which will come back into play later on. So go ahead, hit pause, see if you can use Pythagorean Theorem to find the length of your hypotenuse, and then hit play when you're ready to check your work. So I'm going to just label stuff. I know this is C, and that's what I'm trying to find. I'm going to say that this is A and that this is B. So if I do A squared plus B squared equals C squared, that means I'm actually doing 4 squared plus 10 squared equals C squared. I don't know what C is, but I can work out this other side, right? 4 squared is 16, 10 squared is 100. All right, great. 16 plus 100 is, of course, 116. Now, this is the final step that always messes with people. If you tell me the answer is 116, you're not quite right. You're not done. You found that C squared equals 116, but that's not what C equals. Do you remember how to undo a square? Do you remember that you can, just like you undo addition with subtraction, you undo multiplication with division, you undo a square with a square root, right? So I'm going to go ahead and do the square root of both sides. Of course, the square root of C squared is C, right? The square and the square root undo each other. It's why we did it. And then I need a calculator because it did say to round my answer to the nearest tenth. So if I use my calculator and if I use the magic square root button on my calculator, I get a big old number. I get like 10.77032.961. Whoa. You know what? I'm going to round to the nearest tenth, which takes me to about 10.8. So we just found out that the length of that hypotenuse is about 10.8. Now, there's a reason why I made you do this warm-up. There's a method to the madness. So as I said, today we're going to be classifying shapes in the coordinate plane. How do you know that's a square? How do you know that's a rectangle? How do you know that's a right triangle, right? How do we know these things? And so we're going to go through a couple of different techniques today, along with just kind of reminding ourselves about properties of these shapes. And then next time, we'll go into how we can use our techniques from today to prove what we want to know for tomorrow. So our learning goals, we're going to use the Pythagorean Theorem to derive the distance formula. Ooh. So you're used to the Pythagorean Theorem, but it turns out you can push the Pythagorean Theorem just a step further in order to find the distance between any 2 points. It's really cool. You're going to apply that distance formula on the coordinate plane, right? So you've got 2 points on the coordinate plane. Find the distance between those points. Distance formula is your guy. We're also going to be playing around a bit with midpoint formula and a few other things as well. So our key terms today will be distance formula, midpoint, and midpoint formula. Now, you've classified triangles and quadrilaterals by the lengths of their sides, measures of their angles. That's not new to you, and we'll dig into that a bit more today. But how can we classify polygons if they're on the coordinate plane? And that's what we're going to start digging into these next couple days. So to kick it off, and I do warn you, we're going to be jumping around a little bit page to page. We're not quite going in order of what is in your workbook. It's not personal. It's just I felt this was a better way to get you guys where we need to be. So we're going to go, we're on page 247 here. We're actually going to jump over to page 251. So you use the Pythagorean theorem to calculate the distance between 2 points, right? You use the Pythagorean theorem to find the length of C, but you find the length of that side. So we can push this a step further to find any 2 points on the coordinate plane. And this method is written as the distance formula. So the distance formula states that if x1 and y1 and x2 and y2 are 2 points on the coordinate plane, then the distance between them is calculated using this formula right here. Here's the deal. This is a version of the Pythagorean theorem. Okay? If you find the difference between your x's, that will tell you the length of this, right? If I want to know how far it is from here to here, I would subtract my x coordinates, and that would tell me that length. That's like your a squared. Do you see that? Subtract your x's and square it. There's your a squared. This length is the other side of my right triangle, right? If I wanted to find this length, I would just subtract the y coordinates. I was at 5 and I dropped down to 3, so I would do 5 minus 3. That would tell me the length of this side. So that's my b for my b squared. Do you see that? A squared plus b squared. Oh, the only thing is in order to find your a, you have to subtract your x coordinates. And in order to find your y, you have to subtract your y coordinates. And then we just do like we did earlier. You're going to subtract them first. There's an extra step. You're going to square it, subtract it, square it, add them together. And then do you remember on our warm-up, the last step was we had to do the square root to undo my c squared, right? Only we're going to call it d for distance. And we're just going to put a big square root here. This formula is so important. I would recommend highlighting it in your book. Highlight it, underline it, something. I'm going to go ahead and highlight it, just a nice bright, like, oh, this is so important. This distance formula is so important that I'm going to highlight it here in my book. So it's a squared plus b squared, and we're going to do the square root instead of c squared. It's just the Pythagorean theorem. It's our same steps from before. We square it, we add them together, we do the square root to find the distance. Yay. Let me show you how this works. I'm going to make up some points for this, and I'll give you a nice little example. This question is asking, when you use the distance formula, does it matter? Oh, I want my pen back. There we go. When you use the distance formula, does it matter which point you identify as x or y? And the answer is no, it does not. That squared is going to take care of it. So let me show you how this works. I'm going to make up some points. I'm going to say that this is at 3, 2. I'm going to say that's this point. And I'm going to say that this point is at, again, totally making this up. This point gets at about, 7, and it goes up, I don't know how many. 6? Sure. Sounds good. If I want to find the length of this side, anytime you want to find the length of a side of something on a coordinate plane, or you want to find the distance between 2 points, you're going to use the distance formula. So I've got my x and my y, my x and my y, and it doesn't matter which one is first. It really doesn't. So if I want to find the distance, I'm going to set it up. I'm going to subtract my x's, kind of like we did with slope, right? We subtracted our y's on top, subtracted our x's on the bottom. Definitely some similarities here. So I'm going to subtract my x's. I've got 7 minus 3 plus, and that's going to get squared, plus I'm going to subtract my y's. In this case, 6 minus 2. And I will square it, and then there's a big square root. So I've set up the formula. Subtract it, square it, add it, square root. And I'm going to work this out. 7 minus 3 is, of course, 4. Plus 6 minus 2, which is also 4. Next up, I need to square, right? That's my next step, order of operations. Got it. I did my parentheses first, my PEMDAS. And now I'm going to do my exponents next. 4 squared is 16, plus 4 squared, which is 16. And what do we get here? I need my calculator. 16 plus 16 is 32. And last but not least, let's do the square root. That's what I have the calculator for. use my square root button, and I find out that the distance is approximately, and I'll go ahead and round to the nearest tenth, about 5.7, roughly. It doesn't matter which point is first. It just matters that you subtract the x's and you subtract the y's. I will warn you of something to watch out for. Let's say I'd done this the other way and I'd gotten a -4 squared. Please remember that a -4 squared means -4 times -4. -4 times -4 is a positive 16. Please be careful. This is why it doesn't matter if I flip them, because if I had done 3 minus 7, I would have gotten a -4. But -4 times -4 is still a positive 16. So I still get the same number. I still get the same answer. So it's okay. Just make sure you subtract the x's, subtract the y's. You'll be all right. I have a whole bunch of these for you to practice. Are you ready? Are you ready? Are you ready? All right, I got a whole bunch of these for you to practice. I have my little formula off to the side, just gonna help us out. A whole bunch of these for you to practice. Go ahead and hit pause. Use the distance formula to calculate the distance between each pair of points and round your answer to the nearest tenth if necessary. Please show your work. Go ahead, hit pause, work these out, and then hit play when you're ready to check your work. So me personally, when I do these, you don't have to do this, but like just my brain needs a little help sometimes. I like to be like, that's my x coordinate, that's my y coordinate, that's my x coordinate, that's my y coordinate. It just helps me. It just helps me. So I'm going to subtract my x coordinates, right? That goes in here, 1 minus 3, and subtract my y coordinates, 2 minus 7. 1 minus 3 does give me, let me see here, 1 minus 3 gives me a -2. 2 minus 7 is a -5. And of course, -2 squared, -2 times -2 is a +4. -5 squared, well, -5 times a -5 is a +25. 4 plus 25 is 29, and this is why I have the calculator. I was doing all right until then. Turns out that if you round to the nearest tenth, you get about 5.4-ish, something like that. Let's do this one, x, y, x, y. Let's see, I'll subtract my x's. So for my distance, I'm going to do -6 minus 2 plus 4 minus a -8. Hey, look at this. Remember how this works? Double negative becomes a positive, right? 4 minus a -8 actually becomes a 4 plus 8. That's easier to work with. So -6 minus 2 is a -8. And you're welcome to use a calculator if you ever want to double check me. Please double check me. 4 plus 8 is, of course, 12. I'm going to use my, might want to bust out the calculator soon here. -8 squared. -8 times -8 is a +64. Plus 12 squared, I happen to know that's 144. Rock on. 64 plus 144. Hang on. I'm going to use my calculator, make sure I do that right. And I got 208. Please don't forget the square root. That seems to be the thing that people forget at the end. So square root of 208 is, of course, about, sorry, my pen went funky, about 14.4. Last but not least, I got one more. So my distance, again, x, y, x, y. So if I subtract my x's, -5 minus a -6 squared, plus 2 minus 10 squared. Now do the big square root here. God, this needs to be cleaned up. Oh my gosh. First of all, minus a negative, that becomes a plus. Come on now. So -5 plus 6 is 1. Nice. 2 minus 10 is a -8. Of course, 1 squared is 1. -8 times -8 is 64. 1 plus 64 is 65. And that's why I have a calculator. Square root of 65 is about 8.1-ish. Sort of like that. So that's what you're going to be doing for a lot of your homework. You're just going to be using the distance formula. Subtract your x's, square it. Subtract your y's, square it. Add them together, and then do the square root. It's not bad. Especially if you use a calculator. I will say, watch your negatives. Usually students don't have a hard time understanding this. You know how to put it together. You know how to use a calculator. Just negatives get lost. So please be careful, and please, please, please watch your negatives. Now, I did tell you we had a little bit more today, right? We had a little bit more. So you use the distance formula now to determine the distance between 2 points. But what if I want to find the midpoint? A midpoint is a point that is exactly halfway between two given points. It's exactly what it sounds like. It's the middle point. It's the point in the middle of two other points. So to determine the coordinates of a midpoint, we use the midpoint formula. And the midpoint formula states that if x1 and y1 and x2 and y2 are 2 points on the coordinate plane, we're back to that again, then the midpoint of the line segment that joins these points is this right here. Now, please notice midpoint formula is a little different because we're not trying to find a length anymore, right? Now we're trying to find the coordinates of the point in the middle. So for that, we're going to use this formula. And again, if you have your highlighter, this is on page 260. If you have your highlighter, I might highlight like midpoint formula, and I might be all like, it's this dude here. My mental trick for this is if you're trying to find the midpoint, hang on, let me bring back my pen. I like to think of it as the new coordinate is the average of the x coordinates and the average of the y coordinates. Remember average, you add them up and divide by how many there are? Yeah, so that's all the midpoint formula is doing. Add your x's, divide by 2. There's your new x coordinate. Add your y's, divide by 2. There's your new y coordinate. Yay, and that's how midpoint formula works. It's pretty snazzy. It's pretty awesome. So let's go to over page 260 here. We have this lovely square. I would like you to use the midpoint formula to determine the midpoints of each side. I'm going to recommend that you start by labeling the points for each one of these. You might want to start by giving the coordinates for A, coordinates for B, coordinates for C, coordinates for D, and then you can find your midpoints. So go ahead, hit pause, work this out, hit play when you're ready to check your work. So like I said, I'm going to start by writing down what the midpoint is, what the coordinates are. So it looks like this point A is 0, 5. And I'm going to start by finding the midpoint of this one. So B, the coordinates for B are at 5, 0. So if I want to find the midpoint of AB, I'm going to add my x coordinates, x, y, x, y. I'm going to add my x coordinates, so 0 plus 5, and divide by 2. And I'm going to add my y coordinates, 5 plus 0, and divide by 2. And that'll give me my new midpoint. 0 plus 5 is, of course, 5. 5 plus 0 is also 5. If you're not loving the fractions, you are welcome to turn them into decimals. 5 divided by 2 is 2.5, 2.5, boom, boom. Sorry for the bad handwriting. There's a decimal there. So fine, it looks like the midpoint of AB is over 2.5 and up 2.5. Boom, there it is. There it is. There's my midpoint at 2.5, 2.5. Did you keep going for the other sides? Let me grab another color. And I'm going to do the other, some more. Let's do more. So this point, it looks like it's at 0, -5. So got xy, I've got xy. So if I want to find the midpoint of CB, I need to add my x's together, 5 plus 0, and divide by 2. I need to add my y's together, 0 plus a -5, divide by 2. 5 plus 0 is, of course, 5. 0 plus a negative 5 is negative 5. Ooh, sorry about that. We will fix that. Yes, we shall. And you're welcome to do decimals. That's okay. Looks like my x-coordinate then would again be 2.5, but my y-coordinate is now negative 2.5. Sorry, it got messy. Do remember to put a comma in the middle. Do remember to put parentheses around it. It is a coordinate. So it looks like I would go 2.5 to the right and then down 2.5. So here's my midpoint, my next midpoint, 2.5 comma negative 2.5. Yay. Let's do the midpoint of the next side, shall we? So I have point C, but I need point D. It looks like point D is at negative 5, 0. So there's x, y, x, y. So fine, add my x's together. Negative 5 plus 0 over 2. Add my y's together. 0 plus negative 5 over 2. So I have negative 5 halves and negative 5 halves. If I add together the tops. Again, decimals are cool too. So if you'd prefer negative 2.5 comma negative 2.5, also acceptable. Sorry, I'm going off to the side like that. So that means I need to go left 2.5 and down 2.5. And there, oh, the lights came back on. There's my new midpoint. Last but not least, let's do one more. I already have the coordinates. So let's find the midpoint of A and D. So I've got xy, I've got xy. So I'm going to add my x's together. I'm running out of space. 0 plus negative 5 divided by 2. Add my y's together. 5 plus 0 divided by 2. 0 plus 5 is, of course, negative 5. 5 plus 0 is, of course, 5. And if you don't like the 5 halves action, you can totally do it as a decimal. Negative 5 divided by 2 is negative 2.5. And 5 divided by 2 is 2.5. Like all my colors? It's so pretty. So that means this midpoint is going to be left 2.5 and up 2.5, 2.5. There's my last midpoint. There it is, right there. You just found the midpoints. All of the midpoints. Midpoint for AB, midpoint for BC, midpoint for CD, and midpoint for DA or AD. You found all the midpoints. So this is the point exactly in the middle. Look how easy it is to find. I love this. I love this. I'm just going to add together my x-coordinates and divide by 2 to get the new x-coordinate. Add together my y-coordinates, divide by 2 to get my new y-coordinate. I love that. So on your homework, on the worksheet you have for your homework tonight, you are going to be asked to find the distance and the midpoint for every problem. No big deal. All right. Whoa, I went too far. Come back. One last thing I do want to talk about. Page 248, it wants us to cut out the shape names located at the end of the lesson and sort the shapes based on the property assigned to you. Here's the deal. You don't have to cut these out if you don't want to, but I do want us to write on these. Can we write on these? So you're going to want to go over to page 263. I'm going to keep this up on my screen, but go over to page 263, and we're going to write on each of these cards. And you can write on the back if you want, but we're going to write on each of these which properties apply. Can we do that? Can you just take a few minutes to do that? Like for right triangle, which of these properties is true for a right triangle? For an isosceles triangle, which of these properties are true for an isosceles triangle? So on and so forth. You may need to talk to somebody to remind yourself what some of these words mean, and that's okay. Go ahead, hit pause, write the properties on each little card, and then hit play when you're ready to check your work. All right, let's see what we've got here. So for a right triangle, 2 pairs of opposite sides are parallel. I don't usually have parallel lines on a right triangle. I do know that a right triangle is one right angle. So let's see if I can find anything. All angles are congruent? No, because I only have one right angle. At least one pair of perpendicular sides. I'll agree with that. Grab a different color here. So one pair. All right, at least one pair of, And I'm going to use a symbol. Choo, choo, that means perpendicular, okay? Perpendicular sides. A pair of consecutive congruent sides, not necessarily. By the way, consecutive just means they're next to each other, the sides next to each other the same. No two sides with the same measure, not necessarily for a right triangle. Let's take a look here though. Isosceles triangle. Opposite sides are parallel? No. All angles are congruent? No. Remember, isosceles means two congruent sides. At least one pair of perpendicular sides? Not necessarily. Pair of consecutive congruent sides? Ooh, I'll take that. I'll take that. I'm going to use different colors just to help me keep things straight. So that's going to be red. Let's make this one a nice green. So pair of consecutive congruent sides. I can't spell consecutive. You have more space on your cards than I do. Consecutive, I can't spell anymore. Congruent, I'm going to use a congruent symbol. Sides. No two sides with the same measure. No, that's not true. Okay. Equilateral triangle. You know what? Equilateral triangles have three congruent sides, right? That's the deal. All their sides are the same. It's equilateral. So nope, no parallel. It does have all congruent angles, though. If you have all congruent sides, you get all congruent angles, too. So I'm going to write that down on equilateral, all congruent angles. That is true. Perpendicular sides, not necessarily. Ooh, pair of consecutive congruent sides. Yeah, that one's going up. That one's going up. So pair of consecutive congruent sides. Awesome. No two sides with the same measure. That's not true. Equilateral, they're all the same. However, the next one says scalene triangle. Scalene means that none of the sides are congruent, right? That's our deal, no congruent sides. So I'm pretty sure that goes that last one, no two sides with the same measure. That's scalene, right? So no two sides with same measure, right? All right. Don't have parallel. We're not going to have congruent angles. We may have perpendicular sides, but I can't guarantee that. And we definitely don't have congruent sides. Good. Let's talk about a trapezoid. If you've forgotten what a trapezoid looks like, real quick, if you've forgotten, remember a trapezoid? This is not my best trapezoid, but it looks like this. Is that ringing a bell? Little trapezoid. Sometimes they look like this. I mean, they could look like this too. But you get the idea. Those are trapezoids. Two pairs of opposite sides that are parallel. Well, I have one pair of parallel sides, but not two, so that's no good. All angles are congruent? Definitely not. At least one pair of perpendicular sides? Maybe, but not necessarily. A pair of consecutive congruent sides? No. And no two sides with the same measure? Oh, maybe, maybe not. You know what? I'm going to make up my own category for this one. I'm going to say it has one pair of parallel sides, just so I can remember. I know it's not one of our categories, but I think that'll help. Parallelogram. I like parallelograms. I want another color. I'm running out of colors. Let's look at this color. Two pairs of opposite sides that are parallel. Yeah, that's a parallelogram. So two pairs of parallel sides that are opposite each other, obviously, but you get the idea. May have congruent angles, may have perpendicular sides, might have consecutive congruent sides, but not necessarily. All right, let's talk rectangle. You know, rectangles also have two pairs of parallel sides. My writing is small, sorry about that. But I also know that all the angles are congruent because a rectangle has four right angles. So let me grab the other color here. All angles congruent, that's the blue. Okay, so I'm going to say all angles congruent, right? That's important. And at least one pair of perpendicular sides. Yeah, sorry. losing things. Also a pair of perpendicular sides. Wow, those rectangles are busy. So perpendicular sides, I'm going to abbreviate. I'm going to use the symbol to make some space here. So rectangles are busy. Rectangles also have perpendicular sides, right? That's how we get those right angles on. Sides may or may not be congruent. And yes, we definitely have sides with the same measure. The guys opposite each other are the same. Rhombus. Opposite sides are parallel. Yeah, I'd agree with that. So 2 pairs of parallel sides. Angles aren't necessarily congruent, not necessarily perpendicular. Consecutive sides are congruent. Yeah, I'm going to go with this one because it turns out a rhombus, and I'm going to grab a different color here. A rhombus has all congruent sides. So yeah, consecutive congruent sides, I'll go with that. So we'll bring that in. Sweet. No 2 sides of the same measure. No, all the sides have the same measure. All right. Square. Now, a square is a funny dude because he's a rectangle and a rhombus. So that means everything on these guys applies here. And I don't think I have space for that. So you know what? I'm just going to write that a square is a rectangle. And I don't need the arrow there, I guess. Make that go away. A square is a rectangle and a rhombus, right? He's got a square has 4 congruent sides. A square has 4 right angles. A square's got like everything. So the opposite sides are parallel. We have the consecutive sides are perpendicular. All the angles are congruent. Everything happens with squares. Squares get crazy. Oh my gosh, that was a bit much, but it's going to help you with our next lesson. So that's why we finished off with that. While you're not doing that with your homework, you are going to want that information for next time. So I hope you made some notes on that. It's going to be helpful for next time. In the meantime, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, let me know. Come talk to me. I'll help you out. And I'll see you guys later. Bye.